Okay, welcome to Lab 2 for Ag Policy, Ag Econ 410. We're in the fourth week of the semester, so third class meeting. But really we're in the second of a series of 3 labs focused on sort of empirical or quantitative evaluation of policies. We're using spreadsheets to look at some policy aspects. Okay, so at this middle point, we are converting our focus or transitioning our focus from the producer, which is, in economic terms or in economic theory, we might say the agent who decides on output and input decisions, to the market, which is the collection of agents that are going to make transactions. So it includes not just the producer, but also the consumer. Or the supply side, the demand side, if it's probably a better way to say that. We went through the producer problem in the last lab and put together a profit maximization problem and saw how different policy instruments would cause a change to the input and output decisions. And then we focused on how a policy analyst might try to design a couple of experiments that are directly comparable and give some idea about which policy has the more impact and which policies might be appropriate for different objectives. And in fact, I think we sort of identified that if income increase is the priority, then the output policy has sort of the largest effect. But if you wanted to reward the use of one input versus the other, then that's when you typically see subsidies placed on inputs. There are other cases, obviously. So, when we get to the second half of the semester, we have many more discussions on sort of historical policies and why they've been used. We'll see that missing markets or market failure is sort of the prime justification for policy. U.S. ag policy, which is really our topic to the midterm, is less about sort of missing or failed markets, but it's about something we call the farm problem that we've been talking about a little bit, which is sort of low, uncertain incomes. Okay, so what's of interest to us going into this lab is the solution to the profit maximization problem gives you a demand for inputs function. Okay, so it's a demand function or a derived demand function, tells you how much of whatever the input is you want, and you can use that demand for input function to convert to a supply function. They both depend on the input and output prices, and they give you exactly what you'd expect to get from a producer problem. So you get the derived demand and the output supply. Under certain conditions, and we talked about these a little bit in lecture, of competition, we can say that it's fair to add up all the producers and create the supply curve from their total behavior. Well, that's always the case. Under certain conditions, we can say that the representative producer, sort of the average producer, can just be multiplied or scaled up to represent the entire supply. And so as long as things are competitive, so that firms that are too low, firms that achieve low cost are quickly caught up with, right, so that they can't undercut everyone else in the market by price, and firms that are too high cost get exited from the market relatively quickly. So if you have those competitive conditions, then everything sort of regresses to the mean, or the sort of basic minimum. The mean will be achieved at the long run minimum average cost. Okay, so those are the conditions we're working on. We're not going to be testing on those or talking about those, but we should be aware that aggregating is not as simple as just saying if it worked for the one producer, let's just say that producer is multiplied by 500 producers, now we have the supply side. Okay, and so if it makes sense that works on the supply side, right, and that there's some restrictions on how you might build the supply curve from an agent problem, start to think about how income is different across people. and how their buying decisions could be differently influenced. And you start to get a picture of the conditions on aggregation for market demand are actually even more stringent. Okay, so the supply curve aggregation that we're going to use, or the sort of argument, is competitive markets. And that's based on technology and the idea that anyone can get access to the technology. It's not restricted. Market demand is a whole different picture. And because of that, we're going to punt on it. We're going to say that we're going to be able to elicit a market demand from the producer's perspective, so to speak. All we need to know is how much is being willing to be bought, and we're going to sort of ignore the idea that these have to come from utility maximization problems of an agent that have very, very different preferences potentially. Okay, so anyway, just like the agent's reaction at the profit maximization problem level, we expect subsidies to increase output. So instead of pushing us up our production curve, causing us to want more input, in the supply-demand framework, it looks like we're just moving up the supply curve. We are producing more output than we have before. The benefit of going to the market is now that we get some extra measures that are, of course, much more interesting. Now, instead of saying this producer is a price taker, right, and we could say that the market simultaneously determines price and quantity. So we get this effect of scaling up all the producers. If we scale up all the producers and their behavior is to increase quantity, then we expect a market price impact. We expect prices to actually fall. And so that's the one limitation of the agent problem, is they are price takers, but at an aggregate level, if they all behave the same way or increase output, they will lower the price. And so that's why we have to get to this case. The second piece is we can now estimate not the taxpayer cost, which is tiny for an individual agent, but of the actual subsidy program. We can put it relative to the size of the market. Okay, so how many units are sold, how much per unit gets tacked on by the taxpayer, and how big is it relative to the value of this market, right? So how heavily supported is this market in its valuation? And then finally, we can do welfare, which is the topic we'll work on between this. Well, we'll work on market supply and demand in between, but we'll move our way towards welfare for the next lab. So lab 3, 1 week from now, we'll focus on doing welfare evaluation, consumer and producer surplus. Okay, so what is the supply function? Well, simply enough, I modeled two things here. I modeled the output response in blue and the input response in orange so that's why it says quantity here of X or Y. So X is on the orange, blue is Y, the output, in response to the price ratio. So one way to think about this would be the real or relative price of output, and as the real or relative price of output goes up, you want more input and you produce more output. And this is what our supply curve looked like last week. And so if you take that model that we had, that we used we applied solver to it, and you just keep increasing the price over and over and over, you'll end up with this upward sloping supply. And so this is actually the problem that we're saying, this is the supply response that we're going to need for our representative producer that now represents the entire industry. So that's where we're going to start. So we're going to start by building out a supply curve. We'll add to that a demand curve or a demand function. These are going to look like functions because we're not going to do the graphs in the spreadsheet. And then we need to figure out a way to solve for it. Okay, so here are the basics of market equilibrium. We need a function that tells us how quantity supplied responds to a certain price, the producer price. Okay, so here I've written it. The quantity supplied function is QS equal to some intercept plus some slope parameter multiplied by the producer price. And we're going to keep individual prices here. One, because If you recall, in the lectures this week, we talked about price linkage equations, meaning we need to identify the specific price as it's seen by the supply side. And the same thing we would need to do for the demand side. So we're going to identify producer price, consumer price. If those are the same, then there's no policy in play. If they differ, then there's some policy sitting in between those, between the buyer and the seller. The government or whatever agency is allowed to tax or subsidize has moved in there and put a wedge between the two prices. We have a quantity demanded function, QD. That's the same format. So it has an intercept. We're using linear supply and demand. Has an intercept, a slope, and that slope multiplies by the price and gives us these results. And then the final thing we have is this piece. So it's what we call the market clearing condition. So it's great to have a supply function, it's great to have a demand function, but if you want to have a market-based analysis, right, that it needs an equilibrium condition, and this market clearing condition is that equilibrium condition. It tells us what price, what producer price, consumer price, or eventually market price needs to be set to force the quantity supplied to be exactly the same as the quantity demanded, and that's what we call the market clearing. There's no excess. Okay, so it removes the idea of any excess supply. So it determines the price that clears, excess supply or excess demand, which you might think of as being demand that's unmet or supply that's unsold. Those don't exist because we're only trying to find all the transactions. So every transaction needs a supply side participant and demand side participant. And with that, let's switch over to your spreadsheet and we'll fill it in. So I have here the sheet, on the screen, the numbers we're going to use. So I think I have those down. So let's, if I can get this to switch. Okay, so I've already put in the supply function here and the demand function down below. But this says B3, that's the intercept, plus B4, that's the slope of the supply equation, times B11. And that's down here. This is the producer price cell. Okay, so we're going to determine the producer price somewhere. And it'll tell us, once we know the producer price from the equilibrium condition, we'll simultaneously know the quantity supplied. Sorry. Okay, so that equation's already put in for you. That just means we need to introduce an intercept and a slope. And for the intercept of the supply equation, I put in 0. And I think on the spreadsheet it said 1 for the slope of the supply equation. So this is a pretty simple supply equation. Every time the producer price goes up by 1 unit, we increase supply by 1 unit. So this is one that's easy to do the math with. And it goes through the origin. So when there's no price, you sell nothing. When it's 1, you sell 1. When it's 2, you sell 2. So it's that's why we're not graphing it. It's a simple one to do. If we look at the demand function here, it says B7, pick some intercept, which is located in that cell right below, plus the slope. This is how quantity demanded responds to the price, goes in this cell, and then multiplied by B12, which is the consumer's price. Okay, so let's fill those in. I think they were already filled in on the screenshot from the PowerPoint slides. So that was 100, and this is minus 1. Okay, so this is not always the case. But in this class it is, or any class I teach, I always put the supply function and the demand function in the same format, B7 plus B8. Right, so this says add the slope times the price. And then when I put the parameter in, or I put the value of the slope in, I'm going to give it its negative sign there. Okay, so what we know is that demand needs to be downward sloping. If you always keep the sign with the parameter the slope parameter in this case, then it's quite easy to see. And then of course we're going to do some calculations and some algebra in our lectures that will show you sort of the logic of this. Okay, so we put in these two functions, but it didn't fill in the supply equation here or the demand equation here that I had, and that's because they still need to know what the price is going to be. Okay, so Excel doesn't know, but these say value exclamation point, which if you know what that means there's a formula entered in the cell, it just hasn't been resolved yet. And so for these, the formula says we are going to go to find the producer price. I'm going to take 1 plus B17 and multiply by B14, and we'll think about what that is in a little bit. But the key part here is B14 is the market clearing price. Okay, so the producer price is going to be determined once you know the market clearing price. And if you look down here, you'll see B17 is our instrument. It's our tax or subsidy policy instrument for producers. Okay, now once you look at that, you should have an idea of what the consumer price instrument is going to look like, and that one also depends on B14. So once we know the market price, we are going to be able to fill in these two things will be known. Okay, this one, however, is going to look down here to the consumer. So it's the consumer price is going to depend on what policy what policy instruments or what policy effects we have on tax or subsidy on consumers. Now here's a place where I have put in different signs. Okay, so this one's 1 minus B18. This one's 1 plus B17. And that's because you'll see down here, and I'm going to talk about it a little bit more, I want to have consistency in the way that I use these policy variables. So if TP or TC are greater than 0, I want it to be a subsidy, less than 0 tax. Okay, so this will fill in once we know the price, the market price. This will fill in once we know the market price. That means we need to figure out the market price. Okay, and let me check. Okay, yeah, so we need to figure out what the market price is going to be. So this is giving you a hint here. It says we need a formula, or it's giving me a hint. And it's actually, if we look over here, we see the exact formula we need, QS minus QD. And we can't set that automatically equal to 0, but we can set a formula that says take this value and subtract this value. And so to do that, let's go ahead and enter it. We'll start with an equal sign, and then use the cell reference for QS, or quantity supplied, then give it a minus sign, and then give the cell reference B6 right there says for quantity demanded. Okay, now we have B2 minus B6, and we have this one is converted from a question mark to value, meaning we need to know what the quantity supplied and quantity demanded are before I can impose the market clearing condition. Okay, and so then we get down here to the solution value for the market clearing price. Okay, so it's just written in as words, and so Excel doesn't know what to do with those, so just pick something. Let's put in 4. Okay, well, at 4, at a market price of 4, the quantity supplied is 4, the quantity demanded is 96, and that gives us the quantity supplied minus quantity demanded of negative 92. But the market clearing condition, as it's written here, says that should be 0. Okay, so how do you lower that? Well, let's add 10 to the price. Okay, that's going in the right direction, right? So it's bringing us closer to the market clearing condition. Let's go again, change it to 24. It brought it down again. And you might already see what the pattern is or what the solution is going to be, but we're not going to keep playing with that, changing it one by one. What we're actually going to do is use a tool that's built into Excel, and you have to bear with me here because it's going to be small when I open. It's going to be up here in this part of the spreadsheet. But go up here and go to Data. and then you're going to scroll over until you find what if analysis. Okay, and so it's actually called this forecast tab, forecast section. So you can see the data tools, sort and filter, data tools, forecast, outline, and then from last week we added solver. That's under the analysis tab, but we're going to use this what if analysis. And once you click on the block for what if analysis, you'll see goal seek. And many of you will have used goal seek before, but if you haven't, we'll use it, and I'm going to take you through the steps. So goal seek is basically says, if you open it, it asks you for a set cell, and that's the cell that you want to use, that's the cell that you have a target value for. The second piece here says to value, and that's the target that you have in mind for that cell. And then finally it says by changing which cell. Okay, and so it's this has come out with a bad entry here, so we don't want B14. We're going to click this button, and we're going to select cell B13. Okay, because that's the one where we have a goal in mind, right? So we have a goal that the quantity supplied minus the quantity demanded has to be 0. We shouldn't have any excess supply or demand. And so that means we're going to type in 0 for the to value. So it's set the market clearing equation equal to 0. And how do you do that? You do that by changing the market clearing price in B14. So B13 needs to be set to 0 by adjustments made to B14. Click on OK, and you'll see it scale its way around until it hits what you may have already predicted, the market clearing price of 50. So at 50, a price of 50, the producer price is 50, the consumer price is 50 because we haven't put any tax or subsidies in down here. The quantity supplied is 50, the quantity demand is exactly equal to that at 50, and we have everything sort of built out for a base case at this point. Okay, so let's switch back and let's think about our policy instruments just a little bit, because this is where this is the nature of our class, and we should be preparing to think about this. So we just filled in our spreadsheet for this lab to look exactly like this, and we use goal seek to set this cell to 0 by changing this cell. Okay, so let's think about our instruments. We have two options. We have a demand curve and a supply curve, producer price and consumer price. So that means we have two options to look to interfere in this market, two simple options. And I've used in both cases, you may recognize these formulas, we just looked at them, ad valorem approaches to a consumer tax subsidy and a producer tax subsidy. Okay, so the instruments. TC is going to be our representation for the consumer tax or subsidy variable. Now remember, when we talked in class, for these instruments, you can use one variable, and if it's in one direction, if it's in a direction that improves the agent, right, in this case the purchaser, the buyer, or the consumer, if it improves their situation, we call it a subsidy. If it works against them, or if it's a negative to their wishes about price, we call it a tax. So that means for a consumer price, let's move all the way down here to this equation, the consumer price is equal to 1 minus TC times PM. And I say here that the consumer tax greater than 0, if that rate is greater than 0, then it's a consumer subsidy. And why do I say that? Well, take the market price, and if this subsidy rate is positive, then you have, so let's say it's 0.05, then 1 minus 0.05 is 0.95, sorry. That means you would only paying, the consumer price is actually only paying 95% of the market price. Consumers like low prices. And so that's why we can say, if we write the price linkage equation this way with a negative sign in front of the consumer policy variable, TC greater than 0 is a subsidy, it gives them a lower price relative to the market price. Let's go down here. We have the producer price, and the producer has just the opposite viewpoint of the market price as the consumer. The producer price views it as a subsidy or as a boon or a benefit if the price they receive is higher than the market clearing price. Okay, and so in this case, if we want to make it so that the policy instrument for producers, TP, greater than 0 is a subsidy, we need to write our price linkage equation so that it's 1 plus the subsidy rate. Okay, and so the subsidy rate is given by TP. It needs to be bigger than 0. And so in this case, if we wanted a 5% subsidy to producer price, we would go 1 plus 0.05, which gives you 1.05 times the market price, and that's saying the producer price is 5% larger than the market price. Okay, and so that's how we're going to do those price linkage equations. And so here we have the entries as they'll look in the base case, because we're going to leave that base case to be 0 and 0. So let's go over here. I'll reopen my spreadsheet. So we'll actually formalize that and put 0 and 0, and then the last piece, oh sorry, we'll do that next, is to so our next step is to actually just think about this base case and think about if we want to put policy in, we should do it in a way that lets us compare it directly to what happens when there's no policy. And so that's one of the nice things about doing these kind of policy models, especially supply-demand models in a spreadsheet, is we can just actually copy this entire column. And so the way I copy and paste, I don't know how you do it, but is to highlight all that, and I hit Control-C, and that copies everything, and then hit Control-V, and then whatever it takes to sort of spread it out to the same size. And so what it does is it copies any values that are typed over, but then it also copies the formulas in a relative fashion. So if you've never looked at this, like this, that's not a formula. There. This formula shifted all those formulas that said B7, B8, and now they say C7 and C8. So it knows how to copy those over. There's some cases where you have to be careful where you maybe had a absolute reference, but not in this model, the way we've done it. So in this one, we can copy this over, and I'm just going to type counterfactual here. And our counterfactual is going to be fairly simple. It's going to be what happens if there's a 1% subsidy. Okay, there's a 1% subsidy to the producer introduced in this market. What do we end up with? We end up with quantity supplied of 50.5, right? They are responding to this higher price that they see. The consumer demand didn't change. They don't look at the producer price. So they see 50. They have a consumer or quantity demanded of 50. We have an imbalance here. So our base case worked fine. Our counterfactual now has an excess supply. That means we don't have the market clearing price right? So when we put a subsidy in, you end up moving the supply side up there, moving up the supply curve, but you didn't do anything yet to the other side of the market, the demand side. And so we would need to actually go into goal-seek and resolve for this column solution. And let's go ahead and do that. I forget where it is. Data, what-if analysis, goal-seek. And so now I'm going to take, okay, it's already looking at C13 for me. So C13 needs to be set to the value 0. And for the changing cell, we're going to pick the market clearing price again. Okay, so we're going to force adjust C14 so that the result in C13 shows up to be 0. Hit OK, and here you have it. Okay, so what actually happens when you put this producer subsidy on in this market, you add this producer subsidy of 1%. The phenomenal, or sort of the the tradition, or the bad choice, or the bad idea, or the wrong-headed thinking is to say, well, the price is 50, 1% subsidy to that is 50 cents, so producers are going to get a price of $50.50. But they don't, right? When they increase supply, the demand changes, and the price that the demand side of the market is willing to pay changes, and it actually moves down. And so what ends up happening is you put a 50% subsidy, you were trying to put a 50-cent subsidy in place for producers, but the 50-cent gap ends up being taken up somewhat by consumer benefit. Consumers used to pay 50 cents, 50 units, whatever this is. So consumers used to pay 50, they now get 40 to pay 49.75. Producers are only guaranteed to receive 50 cents higher than this price. Okay, so what we end up with is the gap stays at 0.5, but they share the subsidy, so to speak. Right, so some benefit goes to the supply side of the market, some benefit goes to the demand side of the market. And so there are lots of cases where we have ideas, or policymakers have ideas about how they're going to subsidize something, and you call it leakage or bleeding of subsidy. It's because they haven't taken into account what are the actual supply-demand responses in the market. I think we have one more thing to add to our spreadsheet. Let's look at the slides, and here it is. We are going to introduce something that we call the policy cost. This is the taxpayer burden, so to speak. And that's just going to be as simple as coming up with formulas that we can type in here and say, this is the rate of the policy. Okay, and that means you'll be multiplying this rate times the price, and then we have to pay that rate on every unit. So we'll multiply the rate times the price times the quantity, and we'll get the total spending on the subsidies. And of course, if we were taxing, this will go negative, and it'll be a reduction, right? It'll be a savings to the taxpayer budget. So you don't have to tax somebody if you're taking in taxes from a market. The transfer goes in the opposite direction. But let's put this in. So this formula is probably easier to type over here, so we will actually see a result. So it's going to be equal to the producer tax or subsidy rate multiplied by the producer price, right? That gives you the per unit subsidy amount. And then we need to multiply by the total quantity in the market. And so we'll just use the quantity supplied for that. Okay, so that gives us one side of it, but we also have a policy instrument for consumers. So instead of just stopping there, we're going to add to that C18, the rate that could be applied to consumers, multiplied by the consumer price, right? So that rate times the price that consumer sees tells us some amount of the subsidy. And then let's multiply by the quantity in the market demanded. Okay. Yeah, I'm still thinking a little bit about how I want this to look. Because eventually we're going to do graphical taxpayer burden analysis, and I'm not sure this is going to match to what we do, but we'll deal with that later. Part of the problem is that these are not exact; these are rounded off. We'll stick with this. So, calculate, as I told you, you can copy it back to the left, and of course we know we'd put no policies in this base case, so whatever the cost is going to be. The taxpayers, this is money leaving, this is money paid out, or the cost of the taxpayer. And if we put a tax on, then we should see this go negative, so that its negative cost is like getting revenue. Okay, so we should have this replicated up to this point. Um, let's go back to the slides. Look at that. Yeah, I'm not sure why I had the policy cost there of 25. That's what I was checking on. But let's go through this. So here are the policy experiments that we can do. 1% subsidy to producers, 1% subsidy to consumers, 1% tax on producers, 1% tax on consumers, and then we'll use the spreadsheet to see multiple scenarios. Okay, so that means you can just keep copying a new column every time, a new column each time, and just change one thing. Be sure to resolve the model, and you should get all the results, right, that you'll want. So you can save them all for your quiz, because your quiz is going to ask you about a couple of different, what are the couple of different results. And then the final thing that'll be in the quiz when you get to it is something that we should look at next. Yeah, so, sorry, let me back up here. Yeah, so in addition to this sort of scenario 1 through scenario 4, which you can just keep making new columns, but remember, so we've already done for counterfactual, the column we just titled counterfactual, the first of these policy experiments, but do these next 3, and I'll show you how to set those up in just a second. Do each of those 3, but don't forget you have to redo the goal seek for each of those 3. Okay, so that means you're going to run goal seek 3 times, column by column, and then we're going to look across those, and you'll have all those results for the quiz. It's just an online quiz at the end of this that you can take and report your results. But the last thing, and something we're going to get to in class, is I would also like you to play with the idea of what's the role of the supply and demand response. So one of the things you're going to notice when you get these results are sort of a balance. I mean, we've already talked about the subsidy to producers in the column we filled in, the one policy experiment we did. A subsidy to producers ends up being sort of shared, because the old price was 50. The consumer sees their price go down by 25 or 0.25, and the producer sees their price go up by 0.25. So instead of a 1% subsidy, they both get something like a 0.5% subsidy, and that's the net effect of it. And so one of the things that we need to sort of come to terms with is, how do the supply and demand response determine those impacts? And it's something that is important, and we call it incidence. It's basically saying, if you go to a market and you interfere in a market as a government with some tax or subsidy, how is the impact played out on the two sides of the market? And so I'll give you a couple of suggestions. So that question is going to ask something about how does the supply response being larger than the demand response, or I haven't written the quiz question yet, so I'm not sure what it is. But if you wanted to test this out, you would change when we say supply response and demand response, we're talking about the slope parameters, okay? And we're talking about them in absolute value terms. And so when I go back to the spreadsheet, I will play with this and show you what I mean by increasing the supply response relative to demand response, increasing the demand response relative to supply response. And then who gets the more benefit from a subsidy introduced in the market? Well, the easiest way to play with that is to think about, compared to the base case or the no policy case, whose price goes up more if it's a producer, or down more if it's a consumer? Who's getting more of that gain, right? But you have to keep in mind that they view improvement, they view improvement in different directions. Okay, so with that, let me okay, so let's first of all, yeah, if you wanted to run all the scenarios that were asked of you, the easiest thing to do might be copy that 4 times. something like that, and then maybe go producer subsidy, consumer subsidy, producer tax, consumer tax. Okay, and you can see the imbalance gets introduced. Well, obviously this solution's already done. We end up with an imbalance in supply and demand here and here, but not here. So that's interesting, and that's something you should think about right away, right? Why does this one work and these two don't? But anyway, so those will be the 4 solutions. You need to run goal seek again on this column. If we were to retitle these to something like they were listed in the PowerPoint slides, it would look like that. So scenario 1, 2, 3, and 4, a rerun goal seek on scenario 2 and scenario 3. And of course, what's interesting then is if scenario 1 matches up to scenario 4 in some way, right, in terms of it being the equilibrium, is the same thing going to happen when you look at scenario 2 and scenario 3? Okay, so anyway, those are the 4 things you have to run for your quiz, so run through and do goal seek on those. But the last thing I mentioned there would be a quiz question on is playing with the, let's focus on this column. I want to change it here because I want it to be right next to the base. What happens if supply is more responsive to price than demand? And there's just no simpler way to do this than to either double it or I want to triple it. And so now what I'm saying is the slope of the supply curve is 3 times that of the demand curve in absolute value terms. Okay, so I'm comparing this cell to this cell. Demand is a downward sloping phenomenon. Supply is upward sloping phenomenon. And if you think about those in terms of sort of how fast does quantity adjust to a price change, this would say that supply is much faster in terms of responding. Okay, and so what we can do here is just go back to our goal seek. It's under what if analysis. Click on goal seek. We're going to set C13 equal to 0 by changing the cell, the market clearing price cell, and click on OK. All right. Oh, sorry. And then sorry, I'm going to pause here. Okay, yeah, I sort of misled you there. We can't compare the counterfactual to the base because the supply response is different in these, right? So it's a very different supply curve. What we actually want to do is, in the policy experiment, it's very different. But what we can do is compare it to scenario 1. Okay, so it's actually here, column C and column D. So the results are different. You're going to just kind of look past that a little bit. But here's the key part. Here, if you compare this to the market price, sort of the middle price, the 50-cent price, the producer price goes up by 25, consumer price went down by 25. I can tell you here the basic solution is 25, and so it's sort of like 6 cents of the subsidy is going to the producer, 19 cents is going to the consumer. Okay, and so maybe a simpler way of doing this, if we want to compare it to this scenario 1, is not to make it so large, but to make it only slightly larger. Okay, and so maybe I got too excited. So let's go to goal seek, set that value to 0, by changing the cell of the market price. Okay. And so here you can see that the more responsive supply is, the lower prices get. And that's just because there's more supply, more response in the market altogether. But the consumer price and producer price gap is shrinking. It's because the producer price or the producer gains from this are not going up as much. And you could validate this all kinds of ways. The key part here is these things are going to matter, and we're going to uncover those. I'm going to leave out the quiz question because I didn't give you a good experiment to test here. But the key part is we're going to uncover in class algebraically a direct proof that tells us how to compare the supply parameter for slope and the demand parameter for slope, and use those to predict exactly who benefits and how much they benefit from a policy. Okay, so it's not clear the way we've set up our scenarios here what the base case is for each of these that we should be comparing to, because we are changing the solution every time we change one of these two. Okay, so run these, remember, goal seek every time, and then you'll fill in your quiz based on these solutions over here that you end up with. With that, we'll close out this lab just a little under 50 minutes.